Hi, everybody. Welcome to your Chapter 6 massive review video. I know the one for Chapter 5 was like 3 years long, so I'm going to try and expedite this one a little bit, but we'll see. Please enjoy these special fonts that are downloaded. That is a shout out to my algebra class because I know that they always ask for the best fonts just for them. So here you go. All right, so here is what will be in this video and on your Chapter 6 assessment. So first of all, we're solving systems using 3 ways: graphing, elimination, substitution. So I'll show you all 3 of those. I'll show you how to solve an application problem, aka a word problem. And we'll spend some time on systems of inequalities because we know those take us a hot minute. Now, before I actually go through how to use the solving methods, I want to talk about the most efficient solving method to use based on your system. So if you look at a system that looks like this here in white, both of these are in slope-intercept form. So your most efficient solving method is going to be graphing. I mean, you could use one of the other ones, but like it'll be the quickest for you to graph those. Wherever they cross, that's going to be your solution. If you see a system that looks like this in the light blue, do you see how you've got the X's and the Y's stacked on top of each other and then your regular numbers? Your most efficient form is going to, or sorry, solving method is going to be elimination. And then my kids, like we've talked about this, where these equations are in standard form. Wow. Wow. Okay. This man needs to work on the writing here. And then lastly, when you're talking about substitution, if you see an equation in which you've got like an x equals or like a y equals 2x, your best solving method or your most efficient will be substitution. So I'm going to quickly go through each of the 3. So let's start with graphing. Okay, my friends, hopefully this is familiar to us. Slope-intercept form. When you look at this right here, M represents our slope. That tells us how to move. B represents our y-intercept. This is always where we start. I am getting a little bit nervous that I'm doing such a terrible job writing. Let's hope this gets better as the video goes on. Okay, not a great start. Okay, so here's the first one. So if I give you this system and I'm asking you to solve it, I see that both of these are in slope-intercept form, which means the best way is going to be for graphing. So let's use purple for this guy. All right, we are going to start at -3. So that'll be right here. And then to apply a slope of 2/3, I go up 2, right 3. And you can do it again and pretend like I have enough space on the graph. Oh my God. Seriously, I am terrible today. Okay, let's try again. So here for your second one, let's use red. We are also going to be starting at +3. And if my slope is a -4/3, I'm going to go down 1, 2, 3, 4, right 1, 2, 3, and then you could keep going. Okay, dude, this is not right. I feel like this is like a system error. This is not me. So I'm just gonna highlight where they should intersect. It's right here. Just pretend like that actually did. Oh my God, this is so embarrassing. And that coordinate pair in which both of the lines intersect at is your solution. So if I look at it, that is 3, -1. Okay, let's give this another try. Okay, here I am. Now, when I look at this system, ask yourself, what is the same? What is the same about this? If you have the same slopes, 5x and 5x, those lines are going to be parallel. Like if I graph this first one, -1 up 5/1, would look like that. My second line, starting at -3 up 5/1. Okay, those look like snakes, but those are supposed to be parallel lines. They never intersect, they never touch. That's going to be no solutions. So, my friends, you don't even have to graph this. As soon as you see 5x and 5x, same slopes, no solutions. They're parallel, they never touch. And if you give me a summative assessment that with like a bunch of snake-looking lines on here, I'm not going to be happy because you actually have rulers and pencils. Okay, lastly for graphing. Now, when you look at this system, this one right here, this one is okay in slope-intercept form. This one, though, we're going to have to mess around with to put it into slope-intercept so that we're ready to graph. But let's do our second line first. So I'm going to start with +3. So here I am. And if my slope is 1/2, I'm going to go up 1 over 2, up 1 over 2, and connect. For this line, it's in standard right now. We need to convert it to slope intercept. So I'm just going to kind of move along here. So right now, I'm going to start by adding 2x to both sides. I'm just going to give me a second. So you've got 4y equals 2x plus 12. Okay, now I've got my variables in the right spots, but remember, we cannot have a coefficient for y, which means we need to divide every single piece by 4. So then you've got y equals, you could leave this as 2 over 4x, or I just reduced it in my head to 1/2 x plus 12 divided by 4 is 3. So now you've got a super cool line in slope intercept form. We shall start at, oh, wait a second. Wait, stop right there. What do you notice? Look, this line is y equals 1/2 x plus 3. This line up here is y equals 1/2 x plus 3. They're the same line. It's the same exact equation. If it's the same thing, that's going to be infinitely many solutions, because if you graph it, it'll be right on top of each other. So just to show you again, so this equation right here, we already graphed it. It's y equals 1/2 x plus 3. When I took this little guy and went from standard to slope intercept, guess what? It's the same equation, and you don't have to do anything. Oh my gosh. It's infinitely many solutions. Dude, math is so cool. Okay, so there you go. Moving on. Let's go into elimination. Remember, when we're talking about elimination, you're trying to find variables that are the exact same. So like 2x and 2x, or 5y, 5y. When you've got those the same signs subtract, opposite signs add. All right, let's make it happen. When I see this system, I see x's on top of each other, y's on top of each other, and regular numbers, aka they're in standard form. That's my clue, like, hello, Miss Levant, you need to eliminate. So when I'm looking at my x's and my y's, first of all, my x's are different, but my y's are the same, so yay, we're going to go ahead and eliminate our y's. If it's negative 2y and negative 2y, same sign, subtract. So first of all, peace out, go away. 5x minus 2x gives me 3x. 8 minus 2 gives me 6. Divide by 3. Oh, sorry. Same sign, subtract. And I get that x is equal to 2. Now, you go ahead and you plug that in your coordinate pair right away so you do not lose it. Well, cool for you. You have x. Now, let's go ahead and solve for y. Pick either equation, whichever one looks better to you. I say top one. I picked, it was random. Okay, so we've got 5x minus 2y equals 8. Now pretend like that actually looks better. Instead of x, okay, this just like straight up looks terrible. I'm so sorry. I simply cannot put this on the internet looking this bad. Hold, please. Feel free to fast forward like 2 seconds. Okay. So I'm just going to use the top equation. So 5x minus 2y equals 8. Now, instead of x, I'm going to go ahead and plug in 2 because I already solved for that because I'm cool. 5 times 2 is 10 minus 2y equals 8. Now, I've got my variables here, so I need to move my 10 to the other side. All right, minus 10 minus 10. Now, I'm left with negative 2y equals negative 2. Divide both sides by negative 2, and you get that y is equal to 1. Put it back into your coordinate pair. Here you are. Your solution is going to be 2, 1. And you're welcome, green and gold, Packers colors. Yes, even better. Now, that's one of your easier systems to solve by elimination, because one of your variables was already set up to eliminate. It's not always going to be like that, and we know that. So here we go. And I gave you a yellow side because I just love you so much. All right, here we are. I see that both of my equations are in standard form, so I'm like, hello, it is time to eliminate. My x's are not the same, my y's are not the same, so you're going to have to multiply one or both equations to make them match. Let's say we're going to get our x's to match. So I'm going to have to multiply this whole thing by 3. So I've got 3x plus 3y equals 3 times 4 is 12. I did not touch my top equation, so I'm just going to rewrite it here. Okay, so I multiplied to make them match. Now I can see that my x's are the same, so I'm going to eliminate my x's, and it's 3x and 3x. They're both positive. Same sign, subtract. Okay, so first of all, make these go away. See you later. 2y minus 3y is a negative 1y. 10 minus 12 is a negative 2. You guys, just being in algebra, like as soon as you see negatives on both sides, those just cancel out. It's y equals 2. And you're going to go plug that into your coordinate pair right away before you forget. Now, you can use any equation to plug back in and solve for x, but look at your look at your bottom one. X plus y equals 4. Take out your y, plug in that 2. What number plus 2 gets you to 4? It's 2. Shocker. And your solution would be 2, too. Okay, so we started at basic level. We're like, okay, these are ready to eliminate. Then we multiplied one equation. Guess what? We're going to make it super lit, and we are going to have to multiply both systems. So here you go. I put it on a purple side because, ugh. Now, you don't have x's that match. You don't have y's that match, which means you're going to have to multiply both equations. You pick if you want to do x's or y's. I'm going to say x because that's just where I'm at. If I've got 2 and 3, my goal number is going to be to get it to 6, which means I'll have to multiply this whole guy by 3. So let's do that. So I've got 6x plus 15y equals 36. This bottom one, 3 times 2 would get me to 6. So 2 times 3x is 6x. 2 times 3y is 6y. 2 times 9 is 18. Okay, number 1, you're welcome for giving you Packers colors again. Number 2, all right, we multiply to make a match. Again, my x's are ready to eliminate, and they're the same sign again. So I'm sorry about that, which means they're subtracting going down. Hello, where's my little pen? Okay, so these are going away. 15y minus 6y is a 9y. 36 minus 18 is 18. Divide by 9, and y is 2. So here you are. And then I'm not going to walk you through how to find x. You can go plug that in. Okay, now here we're going. Substitution. Substitution, as my humans know, is Miss LeMan's least favorite, but that's okay because we're going to do it anyways. So when you see a system that is set up with like an x equals or a y equals, your cue is going to be to substitute. That's going to be your most efficient solving method. Might not be our favorite, but it's going to be our most efficient. So when I'm looking at this one, I see that I've got an x equals 3y, and I'm like, dude, this is going to be substitution. Wherever I see an x, I'm going to plug in this 3y. So here's what it's going to look like. Hold please, hold please. So I've got 2y plus, I'm going to take out my x, and I'm going to plug in 3y. And now let's just combine like terms. 2y plus 3y equals 5y equals negative 15. Why is it writing all slanted now? I thought I got the hang of this. And I get that y is equal to negative 3. So here I am. Now I still have to plug that in to solve for x. Pick whatever equation looks easier. Look at this top one. X is equal to 3y, but guess what? You solve for y. 3 times negative 3 is negative 9. And there you go. Your solution is negative 9, negative 3. Now you can see on my slides, I always have myself like with a coordinate pair set up to fill in. You can do that too. I don't need to do that for you. You can do that too. That's a good math practice. That's what makes you a bussin' mathematician. Yes. Okay, last one for substitution. Right now, I see that my top equation is set up as y equals x plus 1. So wherever I see a y right here, I'm going to take out my variable, and I'm going to substitute in that entire expression. So watch what it looks like. I've got 2x plus 3. I'm taking out my y and giving myself some open space. And I'm going to plug in this entire expression. Now, I'm just going to go through and solve. All right, 3 times x is 3x. 3 times 1 is 3 equals 18. Substitution is a lot of combining like terms, so don't feel weird if you're doing that a lot. 2x plus 3x is 5x. Plus 3 equals 18 minus 3 minus 3. Oh my God. 5x equals 15, and then you get that x is equal to 3. My gosh. That was a lot of work. But now it's kind of easy for us. We've got x, we've got to solve for y. Which equation looks easier to you? Top one. So y equals x plus 1. Okay, take out your x. And you just told me that that was 3. Okay, 3 plus 1 is 4. There's your solution. Very cool, huh? All right, so far we've covered systems of equations, and I know I'm going quickly. I'm just trying not to break the internet with the length of this video again. We've done graphing, substitution, elimination, and now let's go ahead and put that into use with 2 application problems. The key to success with an application problem, aka a word problem: define your variables. Tell me, what does x represent? What does y represent? Write a system, solve, and then put your solutions in context. You need to tell me, are you talking about a kid's admissions ticket? Are you talking about a ticket to a Drake concert? Are you talking about jars of peanut butter? Are you talking about donuts? What are you talking about? That's what you need to do with your solutions. Now, luckily, I love you enough that I set up a whole framework for you to put that all in there. See, I just love you so much. This is what I'm telling you. Okay, let's make me smaller. Okay, here we go. Here's the problem. There's 50 total test questions. There are 1-point questions and 3-point questions, and the whole test is worth 29 points. Actually, I'm going to change this. Hold, please. Oh, wow. Hold it. Let's say 66. I hope that this works. My kids know that we did this example in class and we got a negative, so I had to change it. So let's just hope that this works. They want to know how many 1-point questions are there and how many 3-point questions. So the 2 different things that we're looking at are 1-point questions. So let's let that be x. And 3-point questions. So let's let that be y. Now for your system, if there's 50 total questions, that's a combination of both 1-point and 3-point. So that's just going to be x plus y equals 50. Then we've got a second equation telling us, all right, well, there's 66 total points, and that's a combination of 1-point questions and 3-point questions. So we have our system. We defined our variables. Well, now we have to go ahead and solve. So I'm just going to copy it down here. Just calm down. Don't worry. Oh, I think this is going to work. Yes. All right, when you're looking at this, they're both in standard form. You've got x's, y's, regular numbers. That's your clue, hello, to eliminate. Yes, that's what we're going to do. And some of your variables are already ready to eliminate. Look, you've got 1x and 1x. This is a good day. You don't even have to multiply nothing. So these are ready to eliminate. And they're the same sign, which means we're going to subtract going down. 1y minus 3y is going to give you a negative 2y. 50 minus 66 is going to give you a negative 16. Now, don't be freaked out that you got negatives because you have it on both sides. So when you divide those, it's going to become positive. Negative 2, negative 2. Y is equal to a positive 8. So let's put that in our coordinate pair first. Now, we need to go ahead and solve for x. Well, if I know my top equation was kind of easy, hold on. Let's see if I can make this happen. Not even close. Okay. I am going to use my top equation to solve for my other variable. So I already know that y is equal to 8. So instead of y, I'm going to plug in an 8. And then just using basic mental math, I know that x is going to be 42. Now, that's really cool if you can give me your answer as a coordinate pair, but what really shows me that you know what you're doing is if you put it in the context of the situation. If x is 42, that means that there are 42 1-point questions. If y is 8, that means that there are 8 3-point questions. And if you really want to impress me, put it in a complete sentence. That won't impress me, actually just do it. Okay, let's try another solving or system application problem. Okay, on the first day of the Pastel Celebration Festival. Now, Miss Clay's kids, we call Mr. Patel Mr. Pastel because we just do. And it's his celebration festival. So on the first day, they sold 3 kids tickets, 5 adult tickets, total $18. Wow, big day. On the second day, there were 4 kids tickets, 11 adult tickets, making $37. How much is a children's ticket? How much is an adult ticket? Right away, you can see by the question that they're asking, kids tickets, adult tickets, those are your variables. Let's have X represent kid tickets and Y represent adult. I'm just going to abbreviate. So now you told me what X and Y represent. Good job. Let's write our system. And again, this is another time where Miss LeMan just loves you so much. I color coded the equations. So on the first day, there were 3 kids tickets, 5 adult tickets. Who is going to this festival? And equaling $18. On the second day, blue, we've got 4 kids tickets plus 11 adult tickets, making $37. There's your system. Hopefully you see, you're like, oh man, I know Miss LeMan's going to make me do some elimination here. And guess what? You're right. So I'm just going to copy it down here. So we had 3x plus 5y equals 18. 4x plus 11y is equal to 37. Now, this is one where you're going to have to multiply both equations. I feel like let's get our x's to match because we can get the 3 and the 4 to match a 12. So let's just go ahead and do that. So I'm going to multiply all of these pieces by 4. So I'm going to have 12x plus 20y, my God, equal, I'll just do some quick mental math here. 18 times 4 is 72. Oh, and my pen's gone. Okay. For my second equation, to get the 4 to match a 12, we have to multiply everything by 3. So 3 times 4x is 12x plus 3 times 11y is 33y. Oh, and some more mental math. 3 times 37. Oh my God, I just knew it in my head. 111. Yes. Some of you are messaging me right now and I cannot respond because I'm making your video. So now we've got our system ready to eliminate. And yet again, it's our x's. And these are the same signs that we're going to subtract going down. Well, guess what? 20y minus 33y is negative 13y. 72 minus 111 is a negative 39. And when I divide both of those by negative 13, you get that y is equal to 3. Okay, so that was a lot of work, but we got that y is equal to 3. Now you hang on. I'm going to erase all of this in one shot. Watch me go. Watch me go. Ooh, ooh, ooh. Dustin, no. So close. All right, so as our ordered pair, here's y, here's x. Guess what? You told me that y was 3. Now we need to plug that back into either equation to solve for x. Let's just do the top one. So we've got 3x plus 5y, but we already know what that is. Okay, we're going to go ahead and solve. I bet a lot of you can already tell what this is going to be in your head. Minus 15, minus 15. If 3x is equal to 3, guess what? X is only equal to 1. Now, what this really means in the context of this situation is that if X is 1, a kid's ticket is $1. So a kid's ticket is $1. If Y is 3, an adult ticket is $3. So for the Pastel Celebration Festival, it's so exclusive and so important that tickets are only $1 and $3 for kids and adults respectively. That's embarrassing. Okay, last topic. The last thing that we're going through here is graphing systems of inequalities. Now, this can be kind of a hot mess, but luckily our colors will help us. Just as a quick tip here, if you see just less than or greater than, that means that you're going to be using a dashed line. Okay. If you've got less than or equal to or greater than or equal to, when you see that line there, that's your clue for a solid line. So keep that in mind as we're going. Now, before we go through an actual system, okay, this is not an actual system. This is a single one. Also, cool font, huh? Let's graph one single one before we do a system together. Okay, so for this first one, I'm looking at it and I'm like, all right, I see it's just a greater than sign, which means I'm going to use a dashed line. So let's go ahead and graph it. We're going to start at -5. I'm going to go up 1, 2, 3 over 4. And I'm going to do it again. Up 1, 2, 3 over 4. Now, when you connect these, you need a dashed line. My pen is stuck over there. Okay. And to figure out where you're going to shade, whether it's like up here in this region or down here, we've got to test a coordinate pair that's not on the line. Guess what? The magic coordinate pair is going to be 0, 0. Because it's not on the line, that's the best one to use. Okay, so I'm going to do my work over here. Now, instead of y, I'm going to plug in a 0. I've got 3/4. Instead of x, I'm going to plug in a 0, -5. Guess what? 3/4 times 0 is 0. Now ask yourself, is 0 greater than -5? Yes, this is true. This is true. That means that you're going to shade the part that has 0, 0. Watch me go crazy. Yes. So because that point made it true, it's in the solution region for it. So you shade that part. But if it made it false, do not include 0, 0. Absolutely not. Okay, now let's go to a system. Last slide. Don't cry. Okay, so you've got two different inequalities here. Now, as we did in class, or will do in class, depending on when you watch this, we're going to use two different colors, and we're going to treat them 100% differently. So let's do this first one to start. I'm going to use purple. I'm starting at 2, and my slope is going to be 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And because it's just a less than sign, I'm going to be using a dashed line. So here I am. Now, before I even look at that other inequality, let's just do some shading. So again, guess what? Best day of my life. I can use 0, 0 again. So here's my original inequality. I'm going to plug in a 0 here, 0 here. Is 0 less than 2? Yes, yes, it is. That makes it true, which means that you are going to shade in this bottom region here. Now you can see how this is going to get messy, but guess what? We're going to be fine and we're going to get through it. I will pick out a wonderful color to go on top. Okay, this one's done. And I'm also going to get rid of this so we have some space. Now, your second inequality, we're going to treat completely differently. Let's pick out a lit color. How about orange? Gross. Okay, so I'm going to start at 4. So here I am at +4. Now my slope is a -2, so I go down 2 over 1, down 2 over 1, down 2 over 1. This inequality is a greater than or equal to, which means it's going to be a solid line. So let's connect these points with a solid line. Again, now it looks like we got an orange snake going through here. And to figure out where we shade, we have to use a point not on that line. Guess what? 0, 0 is available for us. So here is the whole inequality. Let's plug in a 0 for both variables. I know that -2 times 0 is just going to be 0. So ask yourself, is 0 greater than or equal to 4? No, no, literally the answer is no. That means that you do not shade the part that has 0, 0. So you need to take your little orange colored pencil or marker, and we're shading this region up here, the part that doesn't have 0, 0, because that makes your inequality false, fake news, absolutely not. And you're just going to shade your little way down here. Oh my gosh. Now, the most critical part of this whole thing is after looking at this coloring mess, you need to identify your solution region for us. Your solution region is wherever you see the two colors overlapping. Guess what? Right here, I see a mess of orange and purple. So you're going to put a big S for super great, super snake, and that's your solution region. Okay. So just quick recap. For chapter 6, all of the things that we went through, we talked about solving a system by graphing, elimination, and substitution. Now, whatever method that you choose, no matter what, your solution will be written as an ordered pair. We talked about application problems with systems, and we talked about graphing systems of inequalities. So thanks for tuning in. Shout out to all my favorite people out there. Like, comment, subscribe. That's all I got for you. That's all I got for you. Good luck on your test. You're going to be amazing. Thanks for tuning in, and much love and peace. See ya.